Hello, everyone. Welcome to the Friday Transportation Seminar hosted by me, Jenny Liu, faculty over at Urban Studies and Planning, and also Professor Monsieur over at Civil Engineering, who is not here today. So today we're very happy to welcome Professor Starr McMullen from she's a professor of economics over at Oregon State University. She got her PhD from Berkeley, which is of interest to me because that's where I'm from. So she does a lot of public policy related work in transportation economics, looking at all kinds of things like competition, efficiency, congestion pricing, VMT pricing, so on and so forth. So I am very happy to have her here today to talk about the determinants of VMT. So I will turn the floor over to Professor McMullen. So just as a reminder, since I don't know all of your names, if you do ask a question, please come and check to see if I've marked you down for asking a question at the end. All right, thank you.
Do I need this? Okay. Thank you very much, Jenny. And I'm very happy to be here. I'd like to say that this paper that I'm sort of giving today is very preliminary. It's just sort of shedding some light on some studies that I'd like to do some more of in the future. And as we go on, I'd like to mention that the research for this was originally funded by OTREC, which is the transportation center here. And Nathan Eckstein was a master's student at Oregon State who's since finished. And this is the second paper that's coming out of his work on this project. So before we get started, I thought this is sort of a general outline of my contents, and I'm not used to a 35-minute limit, so I'm trying to be following my outline. I'd like to give you an introduction to why I'm doing this study, and I will give you some general results and some ideas for future research eventually here. I'll give you some idea of my methodologies, et cetera. Remembering that I am an economist, okay? And so I'm going to be interested in behavioral things and various responses to changes in prices and all sorts of things that you might be interested in as well. The background for this paper, this whole research effort, came from some discussions I had with Brian Greger up at the Oregon Department of Transportation. And he's the person who's been developing the Green Step model, which is the model that's supposed to be showing greenhouse gas emissions from different transportation modes. And of course, this is very important because a large percentage of the greenhouse gases are from the transportation sector, and a large percentage of those are from light vehicles. Okay, so this is VMT reduction policies are one of the things that's been suggested to help reduce greenhouse gases from transportation, but it's generally recognized that these can't take place alone. So what they tend to refer to in the policy arena is actually they've been talking about a three-legged stool. This four-legged stool representation was from Cindy Burbank, and she presented this in 2008. The addition there is changes in vehicle system operations that might make for better, for less emissions. I'm not sure exactly what she means, but I think she might be meaning things like ramp meters and things like that to try to make the flow of traffic more even or whatever. The other ones I think are pretty familiar to everybody. One is developing alternative fuels, which depend upon energy sources that that produce less greenhouse gas emissions. And the other one is creating more fuel-efficient vehicles. And as an economist, that's where I've been most familiar with these policies, because if you create more fuel-efficient vehicles, everybody assumes then that you're going to use less fuel, and that's going to have less emissions. But there is, of course, economists have noted that there is some little rebound effect there, right? Because if you produce more fuel-efficient vehicles, the cost per mile of driving is a little bit less. And since we all know the law of demand, the demand for driving depends partially on the price of driving. You lower the price, people might drive a little bit more. So to some extent, you may get more driving, more VMT, even though you may have less emissions. So there's a little bit of feedback effect there. And that's the sort of thing I'm interested in as an economist, because people say more fuel-efficient vehicles, that'll reduce greenhouse gas emissions, reduce energy, petroleum dependence, et cetera. And I'm interested in the behavioral responses, especially ones that might offset the intended goals of these policies. Okay, so the one that Brian Greger was really concerned with up at ODOT was policies to reduce VMT. Now, he didn't really specify how you might do this. A previous study of mine looked at the economic impacts of changing from the gasoline tax for funding highways to a vehicle mile tax, which of course makes the cost of driving per mile more dependent. I mean, it's more of a price incentive there. So you could, I guess, reduce VMT by imposing really high highway user fees. Okay. Other things would be various kinds of mandates. But the question that he's run into when he's presented some of these sort of suggestions that have been put forward to reduce vehicle miles is the question of what reducing vehicle miles will do to economic activity. And why does that say? Oh, I didn't know I had it set up like that. There you go. What's happened is there's been several mandates for things, either greenhouse gas emissions reductions from transportation or in general, and vehicle mile traveled reductions. So when I had VMT here, it's vehicle miles traveled. Okay, these are various legislative acts that have mandated something which is related to greenhouse gas reductions. Oregon State is mandating levels 10% below 1990 levels by 2020 and 75% below 1990 levels by 2050. And so transportation's got to be part of that. Washington State has addressed it directly by talking about reducing per capita VMT 25% below 1990 levels. And the Federal Surface Transportation Policy and Planning Act of 2009 talked about reducing national per capita VMT. And implicit in this idea is that one of the ways to do this is to increase public transportation, other modes of transportation, and for those of you who are from the public planning background, and you'll see further as I go along today, there's other policies that have been suggested, like things like increasing urban density, et cetera. Well, the first study I did for them on this looked at the relationship between VMT and economic activity, and the question we were addressing was, will policies aimed at reducing VMT in order to achieve this goal of reducing greenhouse gas emissions, will this adversely impact economic activity in a metropolitan area? The only study I found that used any analytical techniques, statistical techniques to look at this was a study by Randy Pozdina. Some of you may know Randy. And his argument was that it's possible that if you have mandates to reduce VMT, that could cause all sorts of adverse impacts on economic activity in an area. Okay. So, and he did do a Granger causality test using national level data. And what we did was we basically used these same Granger causality techniques, which are statistical techniques which just show which event precedes the other. Does economic activity increase, and does that cause people to drive more, or do people drive more and that causes economic activity to increase? In other words, what's the causal relationship there? Because in the opposite direction, of course, if VMT causes economic activity to go down, you've got to watch out for your mandates to reduce VMT. So this report that just came out in the Transportation Research Record, we used all sorts of Granger causality tests on all sorts of sample sizes. And we found some interesting ideas, some interesting results. One is that at the national level, for most of the time, income precedes VMT changes, which is what we expect when we look at vehicle miles traveled as the demand for vehicle miles traveled. In other words, if we consider driving a normal good, and usually as people's incomes go up, they drive more. Okay. What we did find, though, was that there seemed to be, while income preceded VMT increases during normal periods, when you entered a recession, VMT, when you have a recession, tended to lead decreases in economic activity, something which I was sort of surprised about until I talked to people back at TRB when we gave our poster presentation, and they said that's what they've noticed at the national level all along. And that's one reason why VMT and our weight mile taxes in Oregon are used as a leading indicator of economic activity for downturns. And if you think about it, and I'll get back to this again later, especially freight VMT, you know, freight moves a lot of goods, and a lot of those are intermediate goods that get used in the production process. So when the economic activity starts, you know, when you're getting into the supply chain, the orders may start falling off. They don't have to deliver as much, and that precedes the actual decrease in income. So that was an interesting observation. The other thing we did, though, was we said, you know, when we look at these VMT mandates to reduce vehicle miles traveled, they may have quite different impacts in different urban areas, depending upon, for one thing, especially for passengers, what the alternatives available are for driving. So in an area that has more transit, you might find that there's less impact because people can easily change over to transit modes, et cetera. Whereas some regions have better bike lanes, like Portland. I just read a great study on bicycle travel that shows that we have like the highest percentage of trips taken on bicycles in the Portland area, but also we have a lot of infrastructure, okay, that's been devoted towards bicycle riding. So what we decided was we would also look at causal relationships at the urban area level. And for this, we used the Texas Transportation Institute data set from the Urban Mobility Study, which you're probably familiar with. And at the time, they had 100 areas, urban areas, and they could only get data for 98 of them for the period 1982 to 2007 or something. And subsequently, we put it through 2009. And what we found is that if you look at the aggregate of the urban area, there's little causation between income and VMT at all, which to me suggests that there's other determinants of VMT as well. And then what they did was they also, in the Texas Transportation Mobility Study, they divide urban areas into very large, medium, and small. And what we found was, while for the most part, there was not much relationship, sometimes the small ones did show a negative relationship. So we decided that we really needed to look at the determinants of VMT activity more closely at the urban level. And I think that this is a very good line of research to continue, and I'm just going to show you the little scratchings we've made at the tip of this iceberg. So our main motivation is to say, is looking at this question of whether VMT reduction policies are going to have different impacts in different urban areas. I've already mentioned the example of smaller urban areas that might lack transit alternatives. And this is sort of like, I've got a whole paper that describes all the data set and everything here. But what it boils down to is of the 100 areas that are included in the Urban Mobility Report, we were only able to get the data we needed for all of them to do a time series cross-section panel study for 87 of these urban areas. And we did it for using data from 82 to 2009. Now we basically then are going to just use standard economic methodologies, econometric methodologies. I know you guys really don't want to see things like this, and I don't want to talk about them either. I let my graduate students do that, and Nathan's great at this. But this model is really from a study that was done by Nolan and Fulton, I believe, and Nolan and Cowart. He's done a couple of studies there, and the big concern for them was they looked at VMT, so they had VMT, that the left-hand side there is VMT per capita in an urban area at time t. And then they have basically two things that you might want to note. The little alphas are group-specific effects. And when I say group-specific effects, we could have like a dummy variable in there for each one of those 87 urban areas. Or we could divide those urban areas into the large, small, medium, and very large groupings. Or we could look at east, west, and central parts of the U.S. So we have different ways we can look at we can classify them. So that's what that little alpha is. The beta is just a year dummy, okay? And then the log of x, those are just all the variables I'm going to say are going to have an impact on VMT. So that's sort of the specification just using an OLS model. And this follows very closely, as I said, Nolan and Cowart. Their big the thing that they were really concentrating on was lane miles per capita. And their question was, you know, if you have VMT, how does driving depend upon how much highway capacity is in an area? And one of the big things that they were concerned about is the fact that if you have more lane miles, that may cause people to drive more. There's more roads available. But there's also an endogeneity, because if you have more vehicle miles traveled in an urban area, then you may get more building of lane miles in an urban area. So their big concern in their study was trying to deal with this endogeneity question with lane miles traveled. I'm sorry, lane miles per capita, or the relationship between how much driving takes place relative to the highway infrastructure. So we have that as one of our variables. We also have an income variable, which is personal income per capita. And we were able to get that for the metropolitan statistical areas, which included these urban areas for all of them. So it's not exactly the same area, but what Nolan and those guys used was the state average income, which to me doesn't really get at, you know, the stuff we want to for the urban areas. And then we only have a state price of fuel, and these are the variables I think could use a lot of work. One is the transit availability. And just from the Federal Highway Transit Administration, we were able to get the transit passenger miles per capita for the urban area. Density is the density of the urban area. So that starts getting at this question that I was talking about. If you have a denser urban area, maybe then people are closer in. They don't have to drive as much. I'm going to return to that. I can return to a lot of stuff. The other thing, though, that we added in here that I was sort of interested in was, does the industry mix in the area make an impact, have a significant impact on vehicle miles traveled in that area? In other words, a lot of people said, well, if you have a lot of financial stuff going on, everybody does things on computers, they work remotely, they don't drive as much, okay? When we looked at these things, we could only get data right now for these sort of really broad categories, and I think that especially with the household survey, the Oregon household survey you have here, you could probably get a lot more interesting information on industry mixes. But this is what we had. And that, as I said, this is just a first preliminary result. The other thing we had was the ratio of public to private employees in the relevant metropolitan area. And this is a two-stage model we did to get rid of endogeneity, which you may or may want to see. But basically all you do is you run a regression with lane miles on the left side, and then you have exogenous variables, and I have urban land area there, which is the same instrument that Cowart and Nolan used. Then you take those coefficients and predict lane miles per capita. So then that's supposed to get rid of a bunch of the endogeneity. We did the standard tests, and it said that that was something that we should be doing. Okay, so this is the basic regression we end up with. I mean, I have tables with numbers if you'd like to see them, but there's so many numbers in each table, it's a little hard to see. So I thought I would sort of give you some of the general information first. One is that that LMPC Starr is that one that's from the second stage least squares. So this is the basic, these are the variables we're looking at. The results we found, we first ran the stuff without correcting for simultaneity or the endogeneity. And what we found is the general results show that obviously when income goes up, personal income per capita is positively correlated to VMT per capita. Lane mile per capita, the more lane miles per capita there are, the more driving there is. However, it looks like a much stronger effect before you account for endogeneity. In other words, our coefficients on lane miles per capita were a lot higher, suggesting an increase of 1% in lane miles per capita would increase vehicle miles driven a whole lot more than it did after we corrected for that endogeneity. I think the coefficient went down by almost half. Okay, so that meant that maybe that wasn't quite as big a determinant there. There's other things going on. What we also found, density, is I just came back from a conference last fall in DC where they were talking a lot about density in urban areas and policies to promote density in order to reduce driving. And in the first set of regressions that we ran, where we didn't correct for this lane mile endogeneity, we found sometimes density had a positive or negative coefficient. Sometimes it was significant, sometimes not. Now, what you'd expect, according to this conventional wisdom, is the denser the population, then you would have less VMT, right? Okay. Once you correct for endogeneity, then that becomes a consistent result. In other words, you always get the negative coefficient, and it's significant. But it's only consistently negative and significant after the application of two-stage least squares. I think there's some other things going on with the density variables, and I think that's the topic for future research, and I have a couple of students who are actually working on that right now. Transit per capita, definitely negatively related to VMT per capita. So, I mean, those are not surprising results, but they're results based upon this data set, and I think there's more work to be done on this. I think that also means that if you need to seriously take into account, for instance, transit availability when you're talking about VMT reduction policies. I'm not sure what my next slide shows. Oh, those are some of the results. If you wanted to see them, we did a bunch of different specifications. Oh, okay. And let me go back here. Did I say anything about, I did say something about the construction variable. We tried different specifications, that public-private employment ratio, and every time we put that in, and we put that in without the finance sector, the construction sector, and the wholesale manufacturing, because of the fact that they're all private employment, and so we were just sort of talking public-private. Every time we put the public-private employment ratio in there, we find more driving. Not exactly sure why, but we don't have any more detailed data to quite get at that. So what we did was a bunch of different specifications here, looking at all sorts of different, the percentage of construction employment always pretty positively associated with driving, and wholesale negatively. This is the specification we use to calculate elasticities and stuff later on. But you can see from the signs there, these are the two-stage models. Yeah, two-stage with different employment mix variables. You can see the predicted lane miles always positive. In parentheses are t-statistics. So you want to have a t-statistic greater than about 2 to have a 95% confidence of a 5% significance level. Personal income, population density, you can see in those two middle ones, it's not so significant. What do you have? Let's see, two-stage least squares with UA. Those are urban area dummies for specific urban areas, all 87 of them, and yearly ones. And then, so those are basic results there. Yes, a 1%, 10% increase in, yeah, those are elasticities because it's all logarithmic form. All these, yeah. So that's what it sort of suggests. This is another specification we did where we, remember I told you that we could specify those urban area dummies. Instead of having 87 urban areas, we could do it by different groupings. So this is the results with no groupings at all. That's regional and year effects. And when I say regional, what they did was, notice we don't have any of these population size variables here. We have central region, eastern region, and in the equation we have with those in them, both of those variables were negative, suggesting in central and eastern there was less VMT per capita, because the region that's left out here is western. Okay, so it means that they all drive less than in the western region of the United States, which makes intuitive sense. And then what we have here, I'm not quite sure why we left out the medium grouping, but we have the small, large, and very large, so it's all relative to the medium. And you can see that the large and very large have more miles traveled than the medium. The small one has less. So basically sort of suggests that as you get to larger and larger cities, there's more driving per capita. So anyway, so these are just some very basic results. These are the ones that I think are sort of interesting for this study. And as I said, we had originally done this study. We did a lot more on this Granger causation. We looked at it for individual urban areas and all sorts of stuff. But so we sort of did this at the end of the study. There's a lot of talk about what's the appropriate measure to use of transit availability in these areas. Urban density, that's one that I think is going to be the source of a lot of research and attention in the future. And I'll tell you what the problem is with it, and that is that when you have higher and higher urban densities, what you find is that, anyway, what we're looking at right now is the relationship between urban density, housing prices, and transportation costs. Because what you have is, we see that places that have higher urban densities have less VMT. However, if as we adopt policies to get the urban densities increased, if that drives up housing costs in those urban areas relative to the housing costs elsewhere, what people base their spending decisions on, or their location choice on, is their budget, and the largest parts of their budget are their housing costs and their transportation costs. So if you can lower your transportation costs, you're willing to take a higher housing cost, but there may be some people who decide that they would rather take lower housing costs, move farther out, and drive more. Okay, so that is the kind of thing that I think is really critical for future research and policy when you're talking about increasing urban density, because you want to be careful. If you increase urban density, you may not find that VMT go down as much as you expect if you get this sort of outward movement. And that's what I'm talking about. Like, remember I talked about the rebound effect from the CAFE standards and the increased fuel economy. Well, I'm sort of thinking there might be something like this. And I have two students right now who are sort of trying to get at some of this by looking at housing prices determinants in the Portland area, et cetera. And I would suspect there's a bunch of you who are also interested in this as well. Other questions have to do with VMT dependence on industry, or industry dependence on VMT, I should say. In other words, which industries are more VMT intensive? Can you, if you find that out and more refine that, can you adopt policies that would encourage certain industries to locate certain places or whatever? I mean, so I think there's a lot more to be done there, but I was just trying to get at some very gross, as in large overall picture looks at things that might affect them. The bottom line is VMT reduction will help. You know, if you can reduce VMT, yeah, can have an impact on greenhouse gases, but I think you do have to be careful about what the other impacts are going to be. And to do that, I think you need to study a little bit more about VMT determinants. So one hot topic for research is using more refined measures of transit and VMT mix, looking at that density, housing, transportation trade-off. The other thing that actually has been mentioned to me by the Oregon freight people is, does freight, these VMT measures that are collected by TTI are overall general VMT, so they're passenger and freight. And there's increasing recognition of the fact that freight traffic is quite different than passenger traffic. In other words, you can't send your freight on the bus. I mean, or you can, but I mean, it's not. That's where you may have more impacts on different kinds of economic activity. So there's a lot of focus at DOTs around the country in looking at ways to increase freight efficiency, and part of that is, I think, and they are also asking the question, what's the relationship between freight VMT and overall economic activity, causal relationships or whatever, and is it the same as what we've just found for the overall VMT? In other words, freight and passenger VMT may respond quite differently to different policies and because they have different determinants. Okay, and then of course with freight you've got urban freight, just the pickup and delivery stuff, but you also have a lot of freight that's going up and down I-5 between Canada and Mexico, the whole thing. So it's quite a complex issue, and I think there's a lot of questions that are open in the freight area, especially when you're talking about VMT reduction. And that, of course, in the freight areas where they've had huge changes engine requirements and emissions requirements for new engines, et cetera. Okay. I think some of these issues can be addressed using some of the TTI data. The TTI data is limited, though, in a lot of ways. You know, the way that they get freight VMT from TTI data is they say, well, historically, we think that the freight is about this percentage of the total VMT, so let's apply that percentage. But I would rather see actual data, and there are some sources becoming available. ATRI has made some available for us in Washington. But I think this new Oregon Household Survey is extremely rich, and I think there's a lot of these questions can be addressed using that, especially this urban density, transportation cost, housing nexus. And the other thing is, another thing I was sort of excited about with the household data is the determinants of bicycle travel. And there's just a great article that just came out in Transportation Research Part A by John Pucher, who I didn't realize was still writing, because he had been out for a long time when I went to grad school. And but it's really interesting looking at, have you guys seen this article? That sort of looks at, it's great, Portland's in there, and this is where I got my, Portland has 5% of the trips on bicycles, because it's, I think it's the highest of all the metropolitan areas that they looked at. But there's also, what you find is there's been increases in bicycle trips, but if you look at who's been increasing, it's mostly men. Women haven't increased the bicycle trips, white men, and in gentrified areas. So, I mean, I think that this household survey has a lot of data on individual trips by bicycle, and you could do a bicycle demand thing. I have a student who's interested in that as well. So, anyway, I'm sort of giving you a brief outline of the sort of things we've been working on. I'd like to refine some of this a little bit more, but I think there's a whole bunch of different issues that could be addressed. So, with that, I have not quite run out of my time, so that means that you guys can ask questions. Yes? Oh, I'm sorry. I guess they have to give you the mic.
Hi, Jamal Green, PhD student in Urban Studies and Planning. Just a couple of questions. When you were talking about your issues with density, I was curious if maybe y'all thought that maybe your density variable was too aggregated. So if you're talking about an urban area, you are talking about a rather heterogeneous density mixture. So we can't assume like a monocentric kind of thing. So I don't know what that would mean in terms of data availability, but you might get a little bit more of that nuance, maybe breaking it down into like TASs or census tracts or something like that.
Right. And actually, one of my students is talking about looking at actually the tax lots and stuff like that, so they can identify it. But you're right about this density measure. This is just for the whole urban area. There might be some parts that are more urban than others, and you may have density in parts that are not close to the urban center. I mean, there is a cost index sort of that's been, I can't remember exactly where it is, but it's called the Transportation and Housing Index. So they combine the transportation and housing costs together and look at that as a composite as opposed to just one or the other. But yeah, no, you're right. There's all sorts of refinements that you can do with that. And that's why this is, what I view these as you can use these. This is better than looking just the national data. Right. So then you're looking at the urban areas, and so you see that there's differences. And there's differences, if you look at different urban areas, there's differences in income per vehicle mile traveled too, quite different ones. And so I just think more research needs to be done on that.
And I was curious about that public-private ratio. Does that include active duty military employees?
Good question. I do not believe so because it's the public ratio of, I don't think it's federal, but I'm not sure. If you pick an area like D.C., I guess it would have to be federal employees, but I wouldn't think that military doesn't usually count in the employment data. So I would think it doesn't because this is from the Bureau of Economic Analysis, or Bureau of Economic Statistics. I can't remember the exactly, but that's a good thing to check out as well.
This is more of a clarifying question. So you had said that in larger cities there was more driving per capita, and I thought that was interesting because I guess in my brain I usually think of larger cities as being more dense cities, and there was sort of the opposite where density had that negative effect. So do those contradict each other, or was there something about sort of that large city by population that they were also geographically large, or why do you think that they had sort of
that's just by population. It's not. And so the only thing there is the classification by population size. And we noticed in this we didn't have population in each city because we mostly did per capita. So we were sort of thinking that would be some proxy for it. I can't tell you. I think there's problems with the the density measure, and I think there may be some endogeneities in there that need to be dealt with as well. But we only dealt with the one endogeneity because that was the one that sort of had been laid out in literature. That's all we had time for at the time. But I think that there's more, and I don't know. Just anybody have ideas? Yeah. Yeah.
I would posit that going back to Holtzclaw, Walters, and Cervero, that density is not really the best determinant of land use. It's been shown to you can have dense sprawl, and if you look like a region like Los Angeles, it's the densest region in the United States, but it's also the most sprawling. And I think this gets back to the VMT question, that a large metropolitan area is just large, so your trips can be longer, just because there's more area to cover. You might have a large area like New York, which has lower VMT per capita because historically it was built with better land use characteristics. But on average, our large, especially in the West, metropolitan areas tend to be large and built in the post-war era where land use was built in an automobile orientation. Whereas I think that the reason why we see this east-west split is the eastern and central cities were built pre-war largely, and so they were built with a better land use mix.
A lot of them were built before they even had automobiles.
Right,
so,
exactly.
I mean,
so they were built in a non-auto-oriented pattern. So I guess my question/suggestion is to go back to some of the other research on land use and see what, like the 8D variables that Walters has spent so much time articulating, which of those could be measured at the metropolitan area?
I do not do urban planning, so I really appreciate this income, but I have no idea what you mean by AD.
Okay, so the 8Ds are density, design, diversity, demographics.
What does AD stand for?
And they're all just words that start with the letter D.
8 Ds.
Ds.
Okay,
Right.
thank you.
So
Okay.
so this is demographics, income, design is street intersections, walkable street intersections per square mile, and then there's pricing is one of those variables. Study area size is one of the variables, and so these are all things that contribute to raising or lowering VMT, especially lowering VMT from baseline. And density is only one of them. And even that density variable is looking at employment and population density, not just population density. So that I would just say that looking at population density alone is kind of a bit of a red herring. And the research has over the past few years indicated that it's not really a good determinant in a VMT, because population density needs to be combined with a bunch of other design variables to actually lower VMT. Otherwise, you can just have dense sprawl. See China, see Los Angeles.
Well, and you also have the, that's what we were sort of trying to get at with this industry mix variable, too. I mean, we're trying to get at some of these other determinants. And since I'm not familiar a lot with that part of the literature, we put that in partially just because we knew that was a variable that people have been looking at. And that's something, we know that that's something that needs to be worked on quite a bit. So I appreciate your input here. And density.
Have you considered looking at household, the size of households? Like a household with 2 adults, they're both driving 10,000 miles a year, is a significantly different driving pattern than maybe a single-parent household that one adult is driving 20,000 miles a year, because that's a 10K per capita, but very different situations. And you make it, if you have one area that has large family size, you may see lower vehicle miles per capita just because there's a lot more children than in an area that has a lower typical family size.
Actually, I have, the thing is that you're right, this is much more aggregate. This is the aggregate for the averages for the whole urban area. In the study that I did on the changing from a gasoline tax to a vehicle mile tax, then we looked at household level data. And when we did that, we had VMTs per household, and we did have some of those variables that you're talking about in there. And boy, I'm trying to remember exactly what the results on the demographics. I was surprised that the children didn't make that much of a difference in VMT, but I think that the male head of household, I mean, there were a few other variables that were in there. And I agree with you. I think that the gender makes a difference in a lot of the activities, and I actually think that's one of the reasons why the women's bicycling doesn't go up quite as much, because they're the ones who usually are trying to ferry the children around and do all these other activities at the same time. But yeah, and so that's something that you can get at with the household survey data. And actually the student I have who is trying to use this data for household VMTs in these 7 areas in Oregon where we have the household survey data available, we are including those sorts of demographic, socioeconomic variables. Yeah.
Hi. This is cool stuff. So I had a question about your transit variable.
Yeah.
You had that in the conclusions as transit availability as a determinant, and was that the TTI, like revenue miles?
No, we did not take that from TTI. And part of the reason we went from 98 to 87 is because some of the data were not available at TTI. So for instance, our income variable, the personal income, we had to get that from metropolitan areas, and TTI, if they had it, I think it was available at the state, which is why I think the other guys used it. The transit, we wanted to use transit seats available, but I think that it's been a little bit since I got through this. I think this was actually just the transit passenger miles of travel per capita. And that was just one we pulled off of, I believe it was the Federal Transit Administration website. So I agree with you that there's a lot of variables, a lot of measures that would be much better for transit. It would be more transit availability that you'd want to see what was going on. So there's endogeneity there as well. Yeah, that's why I say these are very preliminary. I just sort of wanted to throw some things out there and see if I could spark some interest and make some of you go and do some of these things.
All right, we have a question from an online viewer. So the viewer asked, if future transportation funding comes from the VMT tax as opposed to a gas tax, do you believe that there would be any shift in these patterns or not?
In which patterns?
In VMT patterns.
VMT patterns. It depends upon how you implement a VMT tax and what your goal is. What I find is one of the VMT, I like to call it a VMT fee, because to me these are user fees, and so the gasoline tax is supposed to be a user fee as well. But what happens is when you start talking about VMT fees, people start thinking they want to attain a lot of different objectives with this one policy instrument. And basically, it's an instrument for collecting user fees from the roads so you can build the highways or whatever. So the study we did originally for the state, we tried to keep it sort of revenue neutral, so that we just sort of put a VMT tax or VMT fee in per mile that would sort of give us the same amount of tax revenue that you would get if you had the gasoline tax, assuming nobody changed their behaviors. Now, yes, it does change your behavior. It does change the behavior of people traveling, because some people's, if you put in a VMT fee in lieu of a gasoline tax, depending upon the miles per gallons of your vehicle, it changes your cost of driving, and then that changes. Some people drive more, some people drive less. Okay, and that study we did showed the distributional impacts on different groups. One of the interesting things in Oregon was the question: if you did that, what would that do to urban versus rural areas? And people said, rural people in rural areas, they have no choice. They have to drive all these ways, and so if you have a VMT fee instead of gasoline tax, it's going to have a big impact on them, negative impact. What we found was actually, since they have lower miles per gallon vehicles, changing to a revenue neutral fee would actually lower their cost of driving a little bit. And the other thing we found is that some of those people in those areas a lot of them had two kinds of vehicles. They'd have a pickup truck that got a low MPG, but then they'd have a Honda or something that had a higher MPG. So actually, the incidence urban-rural was actually sort of contrary to what you would expect. It was actually more of an incidence on the people in urban areas. So yes, it does change behavior, changing to that. I think that it better ties the use of the highway to the price that you're paying per mile of driving in the highway. And that's because when we first put in the gasoline tax, most vehicles got the same miles per gallon. So what you set it at, everybody was paying pretty much the same price per mile to drive. But what we have now is a big spectrum. And then, of course, you have all sorts of fee structures put in, suggested, where you have higher per mile fee on less fuel-efficient vehicles. You could design it all sorts of different ways. Of course, you could also have some sort of a congestion pricing fees, but that's not that's not just the user fee issue. That's more of a road pricing issue. I don't know if that answers the question.
One thing, can we look at your tables with the results? Again, is that possible?
Which one?
Well, I'm interested in your results for, I think, is it industrial employment or?
Is it this table here or this table?
Or is it, maybe it was.
Oh, the different kinds of employment?
Yeah, the manufacturing employment.
Yeah, the manufacturing employment, yes. That table there shows it as having, these two specifications had the percent manufacturing employment. This one was just construction and manufacturing. And what we found was that it had lower R squared, so we just went for this one instead. I think that that's partially because you can have, I'm not really sure what they're picking up with the wholesale and the manufacturing there, and I think that's something that needs to be looked in. I don't know when they're talking about wholesale. I think the wholesale industry in an urban area can be quite different. Same thing with manufacturing. But go ahead.
Okay. No, I was just wondering, because, so is that not significant to say that manufacturing has a lower ZMT?
Well, it looks like from this it does. I guess the reason that I'm a little nervous about it is that when you do include it, it has the lower R squared, but of course then you may have these other econometrics issues that you may be going on there. I think it's something that needs further exploration. I also think some of these variables aren't very good indicators of the industry mix. But yeah, no, it does. It sort of says manufacturing has less VMT, wholesaling has less also. But construction has more. And I'm not sure about, except why exactly. I don't know if it's because you have a lot of construction workers for huge projects that come in from out of state and then they don't know their way around and they just drive around. I mean, I don't really know what it is. Or whether it's just that they drive more because they're all driving trucks, et cetera. Yeah.
I'm wondering, is lane miles you use as a variable is bigger in urban area compared to the rural area? Because I feel in an urban area, the income is increased, right? And also urban area, there will be more activities, right? And then there will be more the travels on roads. It means there will be more VMT and there will be more the transit miles, right? But I'm wondering if the lane mile is quite many, or the lane mile is very big, and also transit mile is very big, and then
Transit.
Transit
Okay.
mile is big, and rail mile is also big, and then I'm wondering, I'm not quite sure whether people will, I'm not quite sure people choose more transit or people choose more the vehicle. But I feel that if lane mile is less and transit mile is big, and then it indicates that people choose transit compared to the auto in that case.
Okay. You said a couple things. One is urban-rural.
The first question.
Okay, first question, yes.
First question is the easy lane miles are bigger in urban areas compared to the rural areas.
Okay, and I can't really tell you for sure from this study because this study only dealt with lane miles in urban areas. I would think, what you're saying makes sense. I mean, I would say most of the new lane miles that are added seem to be in urban areas, but I'm really not that familiar with the data there. And another point that you're making is that we're really not looking at the rural areas right now. Okay. Now the national data is sort of pooling the urban and rural areas. And so what I've done is I've picked out the urban areas. And the reason I did that for this study is largely because we have all these greenhouse gas mandates and VMT mandates. And it seems to me the urban areas, since they have such a large percent of the VMT, they may be the places where these things are targeted first. So Portland may do something. I mean, as opposed to Baker City out in eastern Oregon. So I don't know exactly that. So you're right, I have nothing on that. I could tell you large versus small urban areas, but I don't have my summary statistics for that particular variable right here. I would also bet that you're right about the transit. I would say that there's probably less transit availability, but once again, we have to get a good measure for transit availability. And that's why I think this Oregon household survey that's available, is just coming available. It does 7 regions around the state, and one of them's Bend, and one of them's Portland, and one of them's, so they're in areas where you would expect to find big differences in transit availability, et cetera. So I think that would be a way to start to see what some of these differences are. I don't know if that answers your question.
Okay, final question.
So this kind of got me wondering about, it didn't look like you studied it here necessarily, but kind of as you see a reduction in VMT, some of that will be due to a reduction in trips, but some of that might also be due to a change in modal choice. And so I'm wondering if you've kind of come across anything like that, not necessarily in this study, but if there's any kind of relationship that you've noticed.
Well, the coefficients in this study on that transit variable are negative. So that basically says the more miles people drive on transit, the less they're driving. More miles, passenger miles they travel on transit, ceteris paribus, the less VMT per capita that they have. And that is a really critical question, which I think, once again, looking at a more micro level, sort of seeing who uses the transit, how much they use it, and whether they have vehicles available as alternatives or whatever, would be the way to do that. So in looking, once again, I'm just sort of, this is off the top of my head because I've just been thinking about this household survey for the last couple days. But, you can get from that how much transit ridership there is in different households, plus the other household characteristics, and get a better idea of, if you change something, is that going to make people switch to transit or bike or walk? They have all those different modes in there. So yeah, that's one of the crucial things for policy is knowing, if you put all this money into this mode, is this going to really shift it, or is there someplace else you could put that same money that you would attain the same overall, let's say, greenhouse gas reduction, but you would get a bigger bang for your buck? That's what economists like to think about.
All right, let's thank Dr. McMullen for her excellent talk.
Thank you.
So please join us next week for a talk about complete streets by 2 speakers from ODOT Region 1. And please turn in your questions and come check with me if you've asked a question as well. Thank you.